Welcome back. Welcome back to Learn with me, Ms. Killen here at MPB. We have come to the end of our Chapter 8 exponential functions. We have this last lesson, and then we will have all the knowledge for these exponential functions. So let's go ahead and look at our lesson 6. We are looking at FBF3, exponential functions, transformations. I can transform and apply horizontal and vertical shifts, reflections, and compressions to exponential functions to create transformations. So let's go ahead and dive deep into this. Let's look at this growth function. We know it's growth because it is increasing. And we're going to say that this is our parent function. Now, when we talk about parent, okay, parent is the beginning of something. Okay, so when you have a parent function, this is the complete beginning of this function. So we're going to call this our parent function. And it says, what transformation can you, or what information can you gain by analyzing this graph? Well, I see that it crosses my y-axis at 0, 1, and then it's increasing, and I can see different points on this graph. So I always want to make sure that I'm analyzing my graphs because 9 times out of 10, you can find loads of information if you'll just analyze this graph. So we're going to call this our parent function. It is an exponential function, and we know that our exponential is y equals a times b to the x. And we also want to make sure that we're looking to see if we can go ahead and write a equation for this. So I have this point right here at 0, 1, and then I've got 1 would be right here, and so here would be 1, 2. So let's go ahead and see if we can write an equation for this function by just getting information from the graph. So let's go ahead. So I've got my first point, which I have x and y. So I'm going to put 1 equals a times b to the 0. Anything to the 0 is 1, so I know that a equals 1. So I have y equals 1. So now let's find b. I have x and y. So let's do this in a different color so we don't get mixed up. So I have 2 equals, we know a is 1, times b to the 1. Anything to the 1 power is itself. I'm going to get 1 by itself, so b equals 2. So I can say y equals 1 times 2 to the x, not to the b, but to the x. Good catch, guys. So for my parent function, I could say that this is y equals 2 to the x. Ms. Killen, you left that 1 off. Yes, I did, because what do I know about multiplying by 1? You just get the number itself, so you don't necessarily have to put that 1. All right, so let's see what we're going to do with this now. It says, consider the transformations. Write an equation to represent each transformation and describe what the transformation is. So if we started with the y equals 2x, what do we notice from our previous function graph, which is here, and what do I notice about to this one? What did it do? It reflected over the x-axis. So it reflected over the x-axis. So how would I write that new formula? All right, so I could go ahead and look at these different points and come up with the different points of using my x-intercept and then where y equals 1, or I can know that when I reflect over that x-axis, I am going to take my original and put put a negative in front of my formula. So when I go from y equals 2 to the x and I flip it, I go to y equals negative 2 to the x. Good job. So now let's look at this next one. We are still comparing it to this one. So when I go from here, my red function, to this other blue function, what have I done? So I know that in my original, my y-intercept was 0, 1, and then I had 1, 2. So they were here, and here. So what happened? Let's use this one. How many did I go to the left? So this is 1, 2. So I went 3 units to the left. That's my transformation. I went 3 units to the left. So I'm moving my x value, so I could say that it is f of x. And when I go to the left, I am adding. So it would also look like this, 2 to the x plus 3. So that's how we're determining, looking at the values of the different amounts of where y is 1 or where x is 1, and then we're looking to see how we can go to that next value when we're doing those transformations. Or when we're reflecting, what happens when I reflect? I'm putting a negative sign in it. And how we're moving to the left, we're adding to our x, or how we're moving to the right and we're subtracting from the x. So all of these different properties that we've learned, we need to make sure that we are putting in to these exponent transformations. So let's look at this slide. What would the graph look like if we transform the graph 2 units to the right? So let's look at the different points we have. We have 0, 1, and we have 1, 2, and we have 2, 4. So there are some points. So if I went 2 units to the right, I would have 1, 2, I would have 1, 2, and I would have 1, 2. So let's look at this. So if this red one is our parent function, there we go. I went 2 units to the right, so instead of 0, 1, now where it's 1, it's at 1, 1. So then if I had my 2, 4, now it's going to be, instead of 2, 4, it's going to be, let's see where it's at. We're at 3, 2. And then instead of that, what was it? What was that other one? We had the 2, 4. And so if we had had the 3 would be coming that 3, 2. And then where that 2, 4 would have been, now we have 4, 4. So the 2 goes to the 4, the 1 comes to the 3, and the 0 comes to the 2. Because there it is. There we go. So that would be my 2 units. So let's look. Here was the original, 0, 1. It's at 1, 1. Excuse me, it's at 2, 1. And then we had at 1, 2. Now we have it at 3, 2. We had it at 2, 4. Now we have it at 4, 4. So it went 2 units to the right. I know that's kind of confusing, but what we're doing is we're just adding 2 points to that x value. That's what that looks like. All right, so the next one says, what if the function had a vertical drop? So what does it mean by a vertical drop? That means I'm going down some. So I'm going 4 units down. Well, when I go up and down, what values am I looking at? So if I'm going left and right, I'm looking at x. I'm looking at up and down, I'm looking at my y values. So if I go down 4, so let's look at this 2, 4. So if I go down 4 units, my new y value for 2 is going to be 0. Let's see if that's the case. So my new value at 2 is going to be 0, and that is definitely the case. So let's look at this one. I had 0 at 1, so now 0 is at 3. So I went down 4 units. So that shows you again what those transformations look like. My horizontal is going left to right. I'm adding or subtracting to those x values. My vertical is going up and down. I'm adding or subtracting to those y values. All right. What are the operation directions? So this is an important slide where you need to make sure that you're getting all of this information. My math operations, if we add inside my parentheses, what am I doing? If I'm adding inside the parentheses, I'm either going left or right. When I am subtracting outside of the parentheses, or if I'm adding outside the parentheses, okay, that's going to look like this. I'm going up and down. So when I am adding inside the parentheses, I am going left. When I'm subtracting inside the parentheses, I'm going right. When I am adding outside the parentheses, I'm going up. When I'm subtracting outside the parentheses, I'm going down. So we need to make sure that we have these in our notes. Now, horizontal and vertical. If we subtract inside, which way do we move? Okay, we're going horizontal. If we add outside the parentheses, which way are we going? We're going vertical because we're going up. Horizontal, we're going left and right. All right, what if we moved, then wrote the equation? So let's see what that looks like. Let's use function, and I misspelled function, guys, and I do apologize. That should look like this. Let's use function f of x equals 3x. So this is our function. So what if we take 3x and we vertically rise 3 units? What is that new equation going to look like? So turn to your table partner and see if y'all can figure this out. I'm going to give you about 15 seconds and see if you can figure out what a vertical rise of 3x would look like. All right, so obviously I'm taking and I am doing a vertical rise, so I am adding to the outside of my parenthesis. So I have f of x equals 3, and I'm going to rise, so I am going to have plus 3. All right, so my horizontal shift left. So what if we took this and said that it was this now? How could I have a horizontal shift when my x is my exponent? So if I have a horizontal shift, that's going left and right. So I've got f of, I'm adding 4 because I'm going to the left. So then it would look like 3x plus 4. So then a horizontal shift right 5. So when I'm going right, I am subtracting. So I'd have f of, let's see, x minus 5, and then I would have 3x minus 5. So then let's go back to the original of this. And if I dropped it down 10 units, what would that look like? So I'm going to have 3x, and I'm going to subtract 10. So check out what we did when we added outside, when we subtracted outside. Maybe I added inside the parentheses. That's what I'm talking about, using these operation symbols as way that we're moving our functions. Good job. All right, let's do some practice. So select the box or boxes that represent the transformation of each function from the parent function. And here's our parent function, x squared. So if I go from x squared and I am raising that x squared and I am taking x squared minus 8 over 7, but it's in my exponent, so what am I doing? I am doing some type of subtraction. So I'm going to do a horizontal translation, meaning I'm going to the right. Now, what if I take my x squared and I put a negative in front of it? I am reflecting. So what happens when I add inside of my parentheses? I am doing a horizontal translation. Now look at this one. I'm adding inside my parentheses, and I'm also adding outside my parentheses. So inside the parentheses, I have horizontal, and outside, I have vertical. Good job. All right, the function h of x equals 3 to the x plus 1 is given in a scenario. Would this be considered a growth or a decay? Now we're having to go back and look at our growth and decay. So would this be a growth or would this be a decay? Real fast, look at your table partner and tell them your answer. This would be a growth, and it is, what's the rate? My common ratio, which is 3. All right, if we have a vertical rise of 2 units, what's the new equation? All right, so a vertical rise of 2 units, what would be the new equation? So I'm going to take it, and I am rising 2. So I'm adding 2. So it's going to be what? H of x equals 3 to the x plus 3. So that would be my new equation. All right. Time for you to master. Now let's take everything we've learned about going in our growth or our decay, going horizontal left and right, or going vertical up and down, and let's put all that together and see what we can do about these problems. All right, so here we go. If you are given the function g of x equals 1/3 to the x, tell what happens in each of the following translations. You can always pull up your notes. So go ahead and pause the video. You or you and your table partner work this table and then come back to me and let's see what we got. All right, so here we go. If I take my g of x equals 1/3 to the x, and in the parentheses, I am adding 2, what type of transformation am I doing? Obviously, I'm going left 2 units. Now, what happens in the parentheses if I subtract by 3? I'm going right 3 units. I know it's kind of opposite, but that's the way it goes. Now, what happens if I'm subtracting outside that parenthesis? I am going down 1 unit. Now, look at this one. What am I doing? I have put a negative in front of that 3. So what happens when I put a negative in front of that 3? Obviously, I've reflected over my x-axis, but now I've also changed that 1, which was right here, and I've multiplied it by a 3, so I am stretching. All right? And then if I add 6 outside of that parentheses, obviously we have gone up 6 units. Good job. Now, you can always take these and plug them in your calculator or plug them in your Desmos, put your parent function as one color, and then do this to each one of them in different colors, and it will show you if it's going right or if it's going left, if it's going up or down, or if it's compressing or if it's stretching. So that's a good thing about using that technology tool. It can help us look to see what we've done. Good job. All right, so which function, g of x, represents the function f of x equals x plus 2 squared minus 1 with a vertical shift of 3 units down and a horizontal shift of 5 units to the right? So what we're going to do here is take what we've done and put that into our function. So Ms. Killen, how do I do that? Well, my function is this. Now, it says I am vertically shifting 3 units down, and I'm horizontally shifting 5 units to the right. So let's work this one first, since we're going left and right first, and that's our x values. So if I'm going to the right, I am subtracting. So I am subtracting by 5 units. So let's subtract by 5 units. So I have x minus 3 by simple operations that we've done. And then it says that I am what? Vertical shift of 3 units. So let's get a different color for that. Let's do purple. Since I am shifting downwards, that is subtraction. So I'm going to subtract here, and I am going to get what? Oh, that's subtraction of 1, not... Okay, so I'm subtracting 1. So I have negative 1, and I am going down, so I subtract it again, so I have minus 4. So my new function is f of x, or it's g of x in this case, equals x minus 3 squared minus 4. So when I'm given a function and it tells me how to work or do the transformation, if I'm going left or right, that's the operation I do to my x value. If I'm going up or down, that's the operation that I'm going to do to my y value, or outside of that parentheses. All right, so let's not forget, add inside, what does it do? It is moving that x value. If I'm adding, I am going to the left. If I'm subtracting inside my parentheses, I'm going to the right. If I subtract outside my parentheses, I'm going down. If I'm adding outside my parentheses, I'm going up. How do you show a vertical translation? Okay, that is going what? Up and down of on your y-axis. So you are adding or subtracting outside the parentheses. And how do you show a reflection? I am putting a negative in front of that number. So we have made it to the end of our exponential unit. It was difficult, but we've gained so much knowledge and you showed so much proficiency with it. I'm super proud that we got through it, and I'm really excited to look into our Unit 9. So thank you for coming to learn with me, Ms. Killen, here at MPB, and have a great day.